Introduction to Exercise 1E on Ratios, Rates, and Best Buys on page 27 of your textbook. Yeah, sure thing. We're going with our do now question of the day. We're making sure that we can round to two significant figures. So for 3,582, what is the second significant figure in this number? 5, thank you very much. So I look at the number afterwards. So after 5 is the 8, I round up. Therefore, it becomes 3600. What symbol should I put before 3,600? Squigglies, thank you very much. Squiggly lines, or approximately 3,600. Second number, what is the second non-zero digit? 9, good. So I look at the number after that. It's 0, which means we round down, and we leave it as 49000. Again, we put the squiggly, thank you very much. Squigglies. Lovely. Pretty straightforward. Content for today, we're looking at ratios, rates, and best buys. Pretty much what we're looking at is comparison, right? Comparison between certain values. And I'm going to separate it into different sections. So it's on ratios, and then rates, and best buys. Am I talking too quickly? No? Lovely. Okay. So ratios. We use ratios to compare quantities with the same units. Can I get you guys to write down this second dot point for me? A to B is written as A dot dot B, or set A colon B. And we treat them very similarly as we do with fractions, right? So we simplify as we do, we multiply as we do, we treat them as the same. Except the only difference is you can have a fraction inside of a ratio, which gets a little bit confusing. When would we use ratios in real life? When would you ever use a ratio? Baking. Can you give me an example? Just randomly come up with something. I don't bake, so you could lie to my face. Good. So 2 parts bread and 2 parts flour, and 1 part water. So that's a comparison. It's a ratio, right? Those, as you notice, is parts, right? You might have 1 cup of this, 2 cups of this. It only works if we have the same units. It doesn't really make sense if I say, for example, 1 milliliter of water per, and then as a colon, 300 grams of this, whatever. It doesn't make sense because it's a ratio. So they have to have the same units. Okay, great. If we're simplifying these ratios, again we treat them as we would fractions. 38, 24, what's the highest common factor? What's any number that goes into 38 and 24? 2. Let's do 2. So I'm going to divide both of them by 2. Again, treating it like it's a fraction, except the line is the colon. That gives me 19 over here, and that gives me 12 over here. Any disagreements? Okay. Is there any way we can simplify that further? No. The only other common factor is 1, and we don't really care. So the 19, 12 is our ratio in the most simplified form. If we go back to the example of 2, 1 being the ratio of flour to water, for example. Again, I don't actually know if that's a real ratio, but let's say it is. What's wrong with me saying 4, 2? Why shouldn't, if I'm writing a recipe, why should I not write 4 colon 2 as the ratio?
Because then you could put 4 cups of flour instead of 2.
Yeah, you could put 4 cups of flour instead of 2 cups of water. I mean, ideally, the result will be the same, right? You still have that much flour, that much water in comparison. However, when you're making a recipe, for example, you don't know how much bread the person actually wants. So you want it to be as simplified as possible so they can do their own math. 2½ and 1/3. What's the first thing I should do? Sorry, what was that? Let's make them improper. So 2½ same as 5 over 2. So that's 2 times 2 is 4, plus the 1 is 5. And then I have over here, I have 1 and 1/3, so that's 4 over 3. Great. I'm going to make them just like we would with fractions. I'm going to make them have the same base. So if I multiply this by 3, multiply this by 3, is that the same as if I multiply this by 2, multiply this by 2? Have I changed the ratio if I do that?
No.
Instead, let's think about it this way. I want to think of it as, let's make them have the same base. Can I multiply each fraction by the same amount to make sure they're the same? Well, of course, that would make sense, right? If I multiply this by 3, multiply this by 3, that's the same as keeping the same number. Is this the same as if I multiplied it by 3 on both top and bottom? Yeah, it is. So I'm going to make them both out of 6. So on the left-hand side, it's 15, because that's 5 times by 3. And the bottom, it's over 6. Is that the same fraction as it is on the left-hand side?
Yes.
It is, great. I'm going to do the same thing on the right-hand side, except of course I'm multiplying by 2, not by 3. So that becomes 8 over 6. Great. Is there any way I can simplify this now? Yeah, Aiden. Sorry? Absolutely. I'm going to get rid of the 6's, because 15 over 6 and 8 over 6 gets really complicated. We could just multiply both sides by 6. That's a mathematical way of doing it. Or we could just get rid of the 6 and write 15 and 8. Because that's the same ratio, isn't it? We have not changed the balance of that. If you were a massive math student and you wanted to make 15 over 6 cups of flour and mix that with 8 over 6 cups of water, it's the same as if you were to do 15 cups of flour, 8 cups of water. The ratio is inherently the same. Can we simplify that any further? No, I'm happy and we're done. Moving on. Unitary method. Does anyone know what unitary means? Uni. What does uni mean?
1.
1. And how do you know that?
Unicycle.
And what's this one called?
Unibrow.
Unibrow and unicycle. Very memorable. So singular, right? So unitary method just means making things in one part. That's it. In one part. The reason I say that is because if we can make it in one part, then, for example, if you're cooking for 7 people, right, and the recipe is for 6 people, you can divide everything by 6 and then times by 7. That makes more sense. You can cook for 7 people as opposed to having to do the math really weirdly. So you can find one part and then multiply it out for several parts or however many parts you need. So in this example, $300 is to be divided in a ratio of 2 to 3. Find the value of the larger portion using the unitary method. Of course, what's the larger portion? 3. Good. How many portions are there
2.
in total?
5.
Yeah, there's 5. So the larger portion is 3, but we're separating into 5s. Does that make sense? So imagine we're separating into 5s. So we have 300 divided by 5, which gives us 60. That's one part. One part. The person on the left-hand side, there we go. The person on the left-hand side has 2 parts. So the person on the left-hand side should have how much? 120. The person on the right-hand side has 3 parts, and we know that one part is $60, which means that the larger portion is going to be 3 times by $60, which gives us an answer of 180. This is how you calculate, for example, a lottery being split up amongst people. Oftentimes, people don't chip in the exact same amount. So maybe if this person chipped in 3 times as much as the other person, how would you calculate it? That's exactly how you would calculate it. Any questions about that? I know I'm jumping through it a little bit quickly, but any questions? Great, okay. Last one. Nope, I lied. Second last one. So, rates and best buys. All we're doing is comparing quantities of different units. If before, for example, we're saying 1 cup of flour, 1 cup of water, it's a ratio because they're exactly the same units. It's still 1 cup. If, for example, it's 70 kilometers an hour, kilometers versus hour, that's a distance versus a time. So they're different units, they're a rate, right? So write these rates in the simplest form possible. So if I'm trying to write 70 kilometers every 2 hours, all I'm doing is writing it as 70 kilometers per hour, which you guys are per 2 hours, as you guys are very familiar with. And then just simplify that. I'm going to divide both sides by 2 to get 35 kilometers per hour. That's the simplest form. Okay, 600 revolutions in 1.5 minutes. There's a few ways you can do this. But what would be the most basic unit? The last one was per hour. What would this one be?
1 minute.
Per minute. So how do we get from 1.5 minutes to 1 minute?
Divide by 1.5.
Sorry? Divide by 1.5. You could do that, but I think that's a little bit confusing. You absolutely can do that. Yes. Say that again, sorry? Yeah, you're right. 1.5, would you guys agree is the same as 3/2? Yeah. I could, and there's a few ways you can do this. You could divide it by 3, or let's times it by 2. I actually prefer times by 2, just to make it a little bit easier. So if I times everything by 2, of course this is 1,200 rev per, how many minutes? 3 minutes. Now we've ended up with whole numbers. We've gotten rid of the fractions. And now we can treat it as we normally would. Well, how do we get to 1 minute? We would divide by 3. Exactly right. Divided by 3. Here we times by 2. So times by 2. And therefore we should divided by 3 here. Divided by 3 gives us 400 revs. Any questions? You guys see how it's very, very similar to what you guys already know with fractions? It's pretty much the same principles, just in a different format. The last one is best buys. Best buys just means which one's a better value. When you go to the shops, oftentimes you'll see, for example, family pack, you're assuming it's bigger, it's most likely cheaper. You should always look at the number at the bottom. It says, for example, $6 per 100 grams, whereas this one is $4 per 100 grams. And you compare the actual value per a same amount, as opposed to just looking at the price, because it gets a little bit confusing. So which is better value? 5 kilos of potatoes for $3.80 or 3 kilos for $2.20? There are two ways you can do this. Because all we're doing is comparing, we can either make them both how much is it per kilo, or we can make them both how many kilos do we get per dollar. Now one of them is harder than the other, but they both work completely fine. Let's do how much it is per kilo, because that seems like the easier method, instead of doing that kind of stuff. So right now it's $3.80. I'm going to write that out here for 5 kilos. I'm going to start with the first one. So if I want to get to 1 kilo, what do I have to do? Good, divided by 5, which means I have to do on this side. What's 380 divided by 5? Yeah, go for it.
Shouldn't be a slash instead of the plate.
Oh yes, thank you for picking that up. It is meant to be a slash. Thank you. All right, so 380 for 5 kilos. What's 380 divided by 5? What's 400 divided by 5?
80.
80. So we're minusing 20, so that actually comes up to 76. So my answer should be 0.76. Is that a hands up at the back? No? If you're not sure, you're more than welcome to use the method here. So that's 5. That goes into 3.8 or 38, sorry, 7 times. And then of course we have 3 remainder. 3 goes into 5 goes to 36 times, gives us 0.76. Great. So we know that this 5 kilograms for 380 costs 76 cents, per kilo. Can we make a decision now as to which one's better?
Not yet.
Not yet, because we need to compare it. Now, you'll probably realize you could, because the other one is 3 kilos, you could just multiply this by 3 to see which one's bigger. But I'm trying to keep it simple and try to compare them if I have 1 kilo of each. So now, I've got 220 per 3 kilograms. So how do I get to 1 kilogram? Thank you very much, divided by 3. Which means I have to divide this side by 3. So that's 220 divided by 3. That goes into there 7 times with 1 remainder. And then 3, ... So I'm going to leave it as that, 0.73. 0.73 per 1 kilo. Which one's better value? Second one. Done. That's it. Okay? Not by much, but they're the same thing, right? So we're saying that this one's cheaper by 3 cents per kilogram. It would work the same if you try and go, how much do I get per $1? And then you can compare which one's better value. Of course, you would want more potatoes for each dollar, as opposed to less dollars per kilogram. I know it sounds like a really weird riddle, but I'm sure you guys will understand as you get going with the questions. Any questions for me?